Writing and graphing inequalities. If you notice, the symbol in white is read less than. So if we had this sentence, it would be read x is less than 5. The symbolic notation, notice sometimes you're taught in elementary school that your inequality sign is going to be open towards the larger number, which means x would have to be less than 5. We can graph inequalities on a number line. Using the number line, we have to have an open circle at 5, because if you plugged in 5 and said 5 is less than 5, that is not a true statement. So 5 doesn't actually work to be plugged in for x, but anything less than 5 does. So we're going to have an open circle at 5, and we are going to shade to the left because the numbers to the left are less than 5, which means that any number to the left of 5 on a number line is going to be a solution, or it would work to be plugged in for x. So in this case, 4, if you plugged in 4 for x, it would be 4 is less than 5, and that is a true statement. 3 is less than 5, and if you think about all of the numbers that would be to the left of 5, all of those could be plugged in for x or substituted in for x, and it would make the inequality true. The next symbol is going to be read greater than. So x is greater than 5 would be how you would read the symbolic notation. Again, we can graph x is greater than 5 on a number line. Just like before, if we plug in 5 for x and we say 5 is greater than 5, that is not a true statement. So 5 actually isn't going to work, but anything larger than 5 will, including like 5.009. That is greater than 5. So we're going to have an open circle at 5, and in this case we're going to be shading to the right because x has to be greater than 5, and the numbers to the right of 5 are greater than 5. If you noticed that the greater than and the less than inequalities were graphed on a number line with an open circle. I kind of talked a little bit. The reason why they're graphed with an open circle is because that number on the number line isn't actually a solution to the inequality. Like I said, if you said 5 is greater than 5, well, 5 isn't greater than 5, 5 is equal to 5. So 5 doesn't work when you just have a greater than or a less than, or your number doesn't work when you just have a greater than or a less than. Now, when we have a line underneath our less than symbol, it is read less than or equal to. So x is less than or equal to 5. Symbolic notation, and then in words it says x is less than or equal to 5. If you plugged in 5 to this inequality and said 5 is less than or equal to 5, would that be true? And the answer is yes, because 5 is equal to 5, so 5 does work for this inequality. Because 5 does work here, we're going to go ahead and we are going to put a closed circle, and we're going to shade to the left because the numbers to the left of 5 are the numbers that are less than 5. Some key words or phrases that you might hear when you're supposed to be using the less than or equal to sign would be no more than, is at most, and has a maximum of. Those words, no more than, at most, and a maximum, should make you think less than or equal to. The next symbol, or the last inequality symbol, is greater than or equal to. So symbolically, we have x is greater than or equal to 5, which is just read x is greater than or equal to 5. Again, I'm going to be able to show it on a graph. And again, because it's an or equal to, I'm going to have a closed circle. So I could plug in 5 again here and say 5 is greater than or equal to 5, and that would be true because 5 is equal to 5. So I'm going to have a closed circle, and I need to shade in the direction that the numbers are greater than 5, so I'm going to shade to the right. Some key words that might tell you to use greater than or equal to would be is no less than, is at least, and has a minimum of. Remember, minimum means the bottom number. That's the lowest that it could be. Now, if you have a minimum of something, then you could have more than that, but you can't have any less. These examples ask us to write an inequality for each sentence. The first one says you need to score at least 30 points to take the lead. If you need to score at least 30 points, you can score 30 points, or you can score more than 30 points. To write an inequality showing at least 30 points, you could use S is greater than or equal to 30. If you only scored 29 points, you wouldn't take the lead. You need to score 30 points or more to take a lead. The next one says the bus seats at most 60 people. If a bus can only seat 60 people, that means that there can be no more than 60. 60 would be the maximum number of people that you could have. So, to write an inequality for this, I'm again going to use the variable s, and s has to be less than or equal to 60, because if you think about a bus, you can't fit more people on than you have the number of seats. That's just not safe, and you're not supposed to. The third one says your waiting time will be 18 minutes or less. If you think about commercials, a lot of times pizza delivery places, a lot of times people will say, we'll have it delivered in 30 minutes or less, or we'll buy it for you, right? So this one says 18 minutes or less. That means they can deliver it, your waiting time will be 18 minutes, or it could be less than 18 minutes. It's not going to be over 18 minutes. So an inequality here would be t for time is less than or equal to 18. And then the last one says at least 15 students must sign up for the school trip. If you need at least 15 students, that means you have to have 15 students or more. If you have less than 15 students, then you're probably not going to get to go on the trip. So an inequality for this would be S for students is greater than or equal to 15. Notice that in each one of these, I had some of those key words that I talked about previously. So if you can understand the key words and which inequality it's going to mean, then that's going to be helpful when you're given a word sentence and they want you to write an inequality. The next examples ask us to graph each inequality. Notice the first one says V is greater than or equal to -1. To graph an inequality, I need to have a number line. Notice I have numbered -3 through +4. Your number line doesn't have to be those numbers, but what number has to be on your number line is -1 because it says V is greater than or equal to -1. Because it is greater than or equal to -1, 1 will be a solution to this inequality, and V has to be greater than or equal to 1, so we need to shade to the right. In the right, if you look at the numbers to the right of -1, all of those numbers are larger or greater than. The next example would be read C is less than 0. Again, I need to have a number line. If C is less than 0, that means that it can't be 0, so I need the open circle, and I need to shade to the left because the numbers to the left of 0 are less than 0. If you look at the next two examples, it says 5 is greater than or equal to y. Sometimes it's really hard to read how you should graph this when your variable isn't written on the left side of your inequality. The good thing about inequalities is that they can be read both forwards and backwards. So I can read this as 5 is greater than or equal to y, and I can also read it the other way and say y is less than or equal to 5. So I can rewrite this inequality by flipping all three parts. So notice in the original 5 is greater than or equal to y. My inequality sign was open towards 5. Because in my second inequality that I've written, y is less than or equal to 5, the inequality is still open towards 5. These two inequalities are saying the same thing. It's just easier to read and know how to graph if your variable is on the left side. So we always want to try to flip it to get it on the left side. But notice you cannot just flip your 5 and your y. You also have to flip your inequality sign. Now I can graph y is less than or equal to 5 by putting a closed dot at 5. And I know I need to shade to the left because to the left of 5 are the numbers that are less than 5. I'm going to use the same idea to graph 9 is greater than z. I can read this as 9 is greater than z, and I can also read it as z is less than 9. So I'm going to rewrite this with my variable on the left. Notice again, I've switched where my z and my 9 are, and when I switch them, I also have to flip the sign. Now I have z is less than 9, which means I need an open circle at 9, and I shade to the left. True and false inequalities. A value makes an inequality true if after substituting or plugging in the value, the resulting inequality is true. If the resulting inequality is false, then the value makes the inequality false. We're going to do 3 examples of this on the next slide. It says to state whether each inequality is true or false for the given value. The first one they give us is y plus 2 is less than 8. And then they tell me that y equals 3. Because they tell me that y equals 3, I'm going to go ahead and plug in 3 for y, which makes this inequality say 3 plus 2 is less than 8. Notice that the 8 is by itself. There's nothing to do to the 8, so I'm going to leave it alone and I'm just going to bring it down. But on the other side of my inequality sign, I have 3 plus 2. We know that 3 plus 2 is 5. Leave the inequality sign alone and bring down the 8. So this inequality for when y equals 3 says that 5 is less than 8. That is a true statement, so when y is 3, the inequality is true. On the next example, they tell me that x divided by 3 is greater than or equal to 4. And then they tell me that x equals 12. I need to plug in 12 for x, which makes this inequality say 12 divided by 3 is greater than or equal to 4. Well, 12 divided by 3 is 4, so I'm going to bring down everything else and I'm going to write 4 is greater than or equal to 4. Because this is an or equal to, this statement is true. 4 is not greater than 4, but 4 is equal to 4, so this inequality is still true. Now on the next example, they tell me 4s is less than 15, and then they tell me that s equals 4. Because they tell me s equals 4, I'm going to plug in 4 for s and say 4 times 4 is less than 15. Well, 4 times 4 is 16. 16 is less than 15. Take a minute and think about that. 16 is not less than 15, but that's what this inequality says. Double check to make sure you haven't made any mistakes up above, and I haven't. So this inequality is not true. 16 is not less than 15, which means that this inequality, when s equals 4, is false.